Well, hello everyone again, and thank you for joining. I think we are ready to start. We have quite some things to show you, so thank you for joining. It is me here today, Ondřej Peterka. I'm the marketing director at GraphAware, and I have with me the pleasure to introduce Christoph Willemsen, who's the CTO at GraphAware, and he will show you how we do enterprise data integration in GraphAware Hume, which is our mission-critical graph analytics solution. Before we get into this, some house rules or guidance. You can always use the Q&A function in Zoom, so please use this for your questions. At the end of the webinar, there'll be time for answering all these questions that we have collected. And there'll be, of course, recording of this webinar afterwards. So if you miss something, you can always get back to it and you will receive this in your email later on. So without any further ado, I will hand over to Chris, our CTO, who will guide you through the rest of the webinar. Thank you for joining again.
Thank you, Ondra. Hi, everyone. It's a pleasure to speak to you today about enterprise data integration tool, and also from Neo4j with Hume, and especially Hume Orchestra, which is our data integration framework. Right, so to start this webinar, I will give a small introduction about what is enterprise integration and how we think about it. So data integration is first and foremost a data challenge, right? So in today's world, we speak about big data, but big data is not the first word anymore, right? So big data is also meaning the variety of data source that you have internally or externally. And the challenge is that you need to integrate systems that are not meant to communicate with each other, right? So there has been a lot of work to make systems like Kafka or JDBC or S3 buckets to be integrated to create a seamless data solution. Enterprise integration is also based on well-known enterprise patterns, so what are called the enterprise integration patterns. This suggests really to look at this website and also the related book, which is already 20 years old, but it's still there, right? So after 20 years, we have more integration and more data, so it's still very valid. Now, what is Hume Orchestra? Well, it's a low-code, user-friendly interface for enterprise integration. So we try to make integration easy and accessible to end users. Orchestra, on its own, is focused really on moving data into and from Neo4j, right? So our primary purpose depends on the needs of Neo4j enterprise projects, right? So this is how we architecture, how we make decision for components, and how we advise with our product customers that are using Neo4j. Orchestra in itself is based on Apache Camel, which is one of the most active top-level Apache projects, and it's also a very mature project. Who is Orchestra for? So I would say that it's mainly for data-savvy analysts. So it can be for developers, of course. It is primarily based for developers, but even non-developers, analysts, the persona of an analyst would be able to use Orchestra. Also, data science teams that want to deliver graph value quickly with a minimum of engineering efforts. So we have put a lot of engineering work into Orchestra that doesn't have to be built and rebuilt across your projects, because we help you with that, right? So it's performant, it's accessible, it can handle failures, so everything is already available to you. And also existing Neo4j enterprise users that want to streamline data ingestion workflows into a unified platform. So probably before knowing Orchestra, before knowing any other tool, people have started ingesting data into Neo4j, and they want to streamline this into something that is accessible, maintained, monitored, etc. Orchestra has a vision right? So we are not any other tool, which is great. But so the vision of Orchestra is that it's integrated into GraphAware Hume, which is our platform for delivering mission-critical graph analytics. It's focused mainly on streaming data, right? So we can, of course, handle batch data, but the real purpose is to handle streaming and near real-time data. We try to make the ease of use without compromising flexibility, right? So some components need some code. This is why we call it low code, like Cypher or a bit of Python to make filters to transform data. But this is really to not limit the user in what they can do. Integrate your own capabilities. So you will see in the demo. So it's not a lock-in. So we actually advise that if you have something working already and you can wrap it under an HTTP service, you can integrate it into Orchestra in really a matter of clicks. And our team of professionals is really dedicated to your Neo4j enterprise integration needs. So this means that because we focus mainly on Neo4j enterprise projects, when you have an issue around integration around Neo4j, then we are there to help you. So it's not, if you open a ticket, it's not number 200, right? So we really focus on this niche and growing niche, of course, but yeah, so we really focus on helping customers doing integration right. A small overview of the features of Orchestra. So first, low code. So it's really a user-friendly user interface that lets you define integration workflows in a matter of clicks and a bit of Cypher or Python. You will see. We have many connectors, so from Kafka, JDBC, RabbitMQ, RSS feed, APIs, almost everything really can be integrated. We provide scheduling as well, so you can schedule workflows to run any time of the day or the night with custom schedules. So this is really helpful. Configuration as code. So everything you will see on the screen today can be configured from code and deployed, automated, started, everything you need to. Secure. So Orchestra is primarily deployed at customers that run in air-gapped environments. So there is no dependency on internet or other things. So we really focus on security, so certificates, encryption of sensitive data, and flexible deployments. So monitoring, so we provide primitive support for monitoring, and we also provide pre-built Grafana dashboards. In terms of the demo today, I will explain what we will show. So we will integrate four data sources, but two of them are mainly the same type. And so we have data in two different Postgres tables, so investment data and acquisitions data. We will import data from real-time newsfeed, so from RSS feeds available online. And we will also tap into a Kafka topic for retrieving historical news. And all of those data sources will be transformed and inserted into Neo4j. Once this is done, because, for example, the real-time news feed or historical news, they contain text, we will show how we can use external APIs, such as Hugging Face, for analyzing text data and store back in Neo4j the result of this text data to enhance the graph we were building. So without further notice, I will switch to the demo. Please, Andrea, confirm you can see Orchestra.
Yes, we can see Orchestra.
Thank you. All right, so I will zoom a bit. Let me know if the zoom is fine.
All good.
Okay, great. So we will start with the first data source here. It's a JDBC compliant data source. So we use Postgres, but we use JDBC to connect to Postgres. So I select a resource. So this is a resource in Hume. It's really a definition of a connection to an external system. So you will create resources for connection to Neo4j, Kafka, Postgres, rabbits, everything. And this is our SQL curve. So we'll select all the data from the investments table, right? Once we will launch this workflow, the data will flow across the lines as messages that will contain the results of the rows of the query. And we will transform those rows into Neo4j data by the help of Cypher. So we will create a Cypher query that will be executed for every row. So we'll just start this workflow right now. And I will stop it just to show how the data is flowing into the system. Right, so here the messages that are incoming are coming as results from the Postgres database. So each row will contain acquirer name and company name, right? So for each of those rows, we will execute this Cypher query. So we'll create an investor for the acquirer, and we will create a company for the company, right? And we will create a relationship between the two nodes that have been created earlier. So let's save this and check the visualization here. So this is the visualization on top of the Neo4j database we are writing to. So previously there was no data, so I will just refresh the page to see the statistics. So we can see here that so far we have created 128 investors that have invested in 136 companies, but of course more than one investor invests in the same company. So in total there are 40 companies, right? And so let's go back to Orchestra. Let's look at the second line. It will be very similar to the first line. So we'll select everything from the acquisitions table now. But instead of creating an investor in a company, we'll create company and company nodes and the acquired relationship between those two companies, right? So I will connect here. On purpose, I didn't connect the components. So that the Cypher query will be executed against Neo4j. I will start the workflow again, right? And while it is running, let's refresh here the visualization. Right. Right. So we can see now that we have created a bigger portion of the graph with the acquired relationship between companies. All right. So now let's go back to our workflow. Let's stop it for now and go back to the next section. Here we will ingest RSS feed. So I can open it here. I can see that I have this feed, right? So if I would open it in the web, this is the RSS feed coming from MarketWatch. And here the RSS feed, if you look at it, can contain actually HTML data. So we want to make sure that the text we are inserting in Neo4j is clean. So we will here use a small Python script, right, that will actually remove and clean the HTML data so that we have clean text. Actually, what this component will do is take the incoming message, the original message, clean the text, and put the clean text into a new field on the message with the clean text, right? So if I'm looking here, I can see I have contents here. This is the original text, and after, so if I look here, I can see I have text full. Here is the text cleaned. So I will also have a Cypher query. Here is a bit more, not complex, but a bit bigger. So we'll create one article node for every feed item that is coming from the RSS feed. We'll set the title, description, type, and the text. We also have information about the author. We will create a relationship between the author and the article. And for the categories, we will create category nodes, but I don't think there are any coming from those feeds, so we will have no category nodes here in this demo. I'll add the line so that it will send the Cypher query to Neo4j as well. Right? And I will start this workflow again. if I go back to my visualization here, we can see that so far we created a couple of articles, 2 authors, and the author relationship. And here is a bit of a shame because we actually have really 2 disconnected graphs. There is nothing that is connecting those 2 datasets, those 3 datasets together, except that one, they are connected to each other. Otherwise, we can see here we have a disconnected domain, actually. So we will see later by the use of the Hugging Face API, how we can merge them together. All right, so a small heads up about the RSS feed is that by default, depending on the RSS feed you're tapping in, they will only return the latest 10 or 20 articles they have on the feed. So this is not a lot of data for a demo. So what I've done here is I have a Kafka topic with historical news that I will also ingest here. But that topic also contains news that were missing an ID. So here, again, I can use a script, a small Python script to make sure that the ID is actually in the body of the message. So if you would look here, right, I make sure that this key in the message exists, right? So it means that we have more data, but only a few of those will actually get into Neo4j after the filter. Right? So I will start this workflow again. You can see here, 596, but only 300 now. Go into, so we can see that this 400 plus articles are already ingested. The acquisitions and investments are a bit bigger, I think 20K or something like this. So while this one is running, I will go over another workflow. So here we have ingested data into Neo4j. We'll use another workflow actually to take the text data from Neo4j, process it with Hugging Face to retrieve mentions of entities such as location, organization, persons, and we will connect those entities. We will actually create those entities into Neo4j and connect them to the articles. So let's have a quick look at the query here. So I find all the articles, find the return the ID and the text. And here I will use a component that is called HTTP enricher. So every API that is reachable by HTTP can be integrated into Orchestra. So be it a SaaS service or your own custom APIs running locally, they can be integrated into Orchestra. So here we see that I will pass the text to process to the Hugging Face API. And I will also use authorization, my authorization token. So this is using encrypted variable. So we don't expose this information into the end user. So we can just make it available securely so people can use tokens into their workflows. We transform a bit the response from the Hugging Face API. So I will create 3 sets per text, a list of person, list of location, list of companies, and I'm returning this as a new message. And then I will write here to Neo4j. So we'll find first the original article, and then we will iterate over the entities returned by Hugging Face, and we will connect them as a mentioned relationship to the article. Okay. Let's start it. All right, so it's running fine. So let's quickly check here the result of the Hugging Face API. So it goes into here, enrich. So we can see we have 29 entities found, etc., etc. So this is the incoming message, right? But I will process this to return only what I'm interested in. So you can see that the outcoming from the script to the Neo4j is just this entities, company, person, location. And then I can use this cipher query to write easily into Neo4j. Okay. So while it is running, let's go back to our visualization. Here we can see still 2 disconnected graphs. Let's refresh this page. And now, beautifully, we have articles mentioning companies that have been acquired by another companies, and investor investing in those companies, right? So I will wait maybe 30 seconds that we have a bit more data into this new Neo4j database. All right, so let's go here. Now we can actually find patterns. So if I go here, let's expand. We start from an investor, so we can look for patterns we have created in the graph. So investor invested in a company that has acquired or been acquired by another company that is mentioned in an article. And let's say that the same article is also mentioning a person. Let's expand this here. Good. So we have found this data. So we have here, for example, this investor that invested in this company that has been acquired by this company. This article is mentioning this company, but also mentioning persons, right? As you can see, every AI service is not always perfect. So we have entities that are a bit off, but most of the time it's working okay. And this is very important also to make sure your text is clean, because if you wouldn't clean the text, it would be sometimes even worse. Okay. So let's go back to Orchestra here. So we're almost finished. All right, so let me stop here. Let's stop the phone as well. I go back quickly to the slides. So I want to speak, this was the graph we wanted to build. I want to speak 2 minutes about small success stories. Of course, I cannot mention every success that has been done with Orchestra, but I want to highlight 2, actually. First one is for a financial risk analysis solution. So really, we train people. We ingested, structured, validated, and of course, this ingestion, structure, validation needs a lot of iteration. So it took about 2 weeks for a lot of data, right? So we're speaking about terabytes of data coming from CSV files, from SQS queues, etc. We also with Orchestra automate risk rules detection. So you can see you can script, so you can read from Neo4j, find patterns, have some rules written in Python that will actually continue in the workflow and send emails, for example. We exposed that service to end users, so external to the organization, and we could actually deliver insights to third parties. So think about people that want to make a loan, and the bank will actually check if this loan is valid, if there is no risk to give this loan to companies, etc. And then it's an internal success story. So Tony, one of our senior front-end persons, actually used Orchestra to connect to real estate APIs in Prague to find apartments. So he was looking for an apartment, and the market is a bit booming. So he connected to real estate API, created some filters from preferences. So he was making sure the results were having some prerequisites based on his preferences. He was sending the results to Slack, and with his wife, they actually were reviewing on Slack the results from flowing the workflow actually and passing the filters. And then they review actually every result. And thanks to actually Orchestra, they were able to be the first person to make an offer for an apartment, and they really had the apartment. So this is a nice business success story for the use of Orchestra. So, and also Tony is not a backend developer or somebody that is used to integrate the systems. So he would really was doing this from the user interface, and it was amazing fine. Right. So maybe Andra, it's time for Q&A.
Yes, yes. Thank you, Chris, for everything. Just a reminder to every one of you, if you have some questions you would like to shoot at us, this is your time. Please send them to the Q&A section, which you can find somewhere around in Zoom. I will start with my own question. I know that Orchestra is still undergoing some developments. It's a live product. So, Chris, if you can show us what's new and what's cooking in Orchestra currently.
Sure. Yeah. So really, the latest release was based on some feedback we've identified working with customers. So some customers do very cool things that we're not especially expecting sometimes. So they, for example, they manage the life cycle of creating Neo4j databases and assigning roles, creating roles and permission. So what you need to know is that in Neo4j, it's creating roles doesn't accept parameters. So we actually, let me quickly show. Here we allowed string interpolation in the cipher query. So I will quickly explain what it is. So you can dynamically compose cipher queries based on the data that is incoming in the message. So let me simulate that you have an incoming message where the data contains the role name, role. It will be analyst, for example. Let's say analyst 2022. And you want to create a cipher query to create that role in the Neo4j database, for example, create role. And you would expect that you would be able to use the cipher parameter role because all the content of the message is injected as cipher parameter. So, and we will write this to Neo4j, for instance, Neo4j writer, and we will select the system database, save, start, and it's running. But if I'm looking into Neo4j, no, this one, 1.74, show roles. Okay, here it's using analyst 22. Okay. And now if I'm doing database test or $1, okay. The other way of doing this, of using parameter, is to be able to do string interpolation. So actually here, I would do this role. It will actually replace on the fly in the text this part with the content of the role here. So instead of using parameters, it will use the value of the file. So let me, for example, change a database here, and put your webinar, save. And for example, I would create a node while the label, for example, is the value of this. Right? It is impossible in Neo4j. You cannot use parameters for labels. So we'll actually do here, so it can go save, and it will run fine because it will create a node with that label. Analyst 20. So without this, it would be impossible. You would have to resort to APARC, and it's more complicated in your queries. So this is one feature. We did a lot of work for people to be able to inject their own Python libraries. So For example, if I show here, webinar demo workflow, this script, for example, if you before the recent addition, you will have to copy paste the script in every workflow, in every component where you need to do the same, right? So now we allow you to actually create a Python file with that script, import it into Orchestra, and for example, you would do import cleaner and just return cleaner dot clean text, but body the text. So, right, so this would be this is much easier for end users that want to reuse scripts they are building. Right? So, and I think one of the biggest improvement with it is that every metrics and message you see here by default are handled in memory. So this means that if you would restart Orchestra or recreate Orchestra on Kubernetes, for example, it would be problematic because you would lose actually track of the messages you processed and the timing it took, etc. So now you can configure the metrics to use a persistent storage, such as Postgres, for example, so that if you need to restart Orchestra, you need to recreate Orchestra on Kubernetes, etc. Well, everything is persisted. So when it restarts, all the metrics will be back and available. So this is one big improvement in the recent releases, and there are other things. Yeah, just look at the release notes. So, yeah.
Thank you. We have some questions from participants. One of them is, can we somehow turn this around? Can we fetch data from Neo4j and pass it to Postgres? The source would be Neo4j, destination would be Postgres.
Yeah, sure. Let me check quickly. Postgres data. Okay, so let's say that I want to take data from Neo4j, so I can do that. That's true. So let's say that I would read all the companies from Neo4j, for example. Neo4j webinar, match, company, return, and dot name as name. Save, then I can persist that to JDBC. Yeah, so we'll be able to do insert into companies, values, name, save, Postgres data, save, and I would have to create a company's database for that. We'll do that. Okay. You don't see it on the screen. This is on my other screen, but this is fine. So it is name, archive. Okay. Let me start this here. Okay, probably I'm not right with the syntax. Okay, that's perfect. So here I'm inserting all the companies into a Postgres table. And to show you it did work, let me delete this and this and do the inverse now. Read from the Postgres database. Postgres data, select all from companies, save, We just put an observer to check the data. And if I start this, oh, 1 second. I don't know what happens. Commit. But let's start again. Neo4j. Now company. Name the name. Let's delete that one for now. Okay. Stop. Let's go back to the data source. Should we see? Let's delete the link to not create it. Right, it is there. Yeah. So we have customers doing that. For example, for powering BI dashboards where data in Postgres is more suited than in other databases.
Perfect. Thank you, Chris. We have some more questions. It's more general one. Is it possible to plug in own machine learning algorithms? Something.
Yeah. So as I explained here, we're using the Hugging Face API. So if your machine learning algorithms are available through an HTTP service, you can plug it in. So we have our own, for example, machine learning for entity detection, keyword extraction, but those are as HTTP-based services. So you can do the same, and we recommend it that you actually let them expose those HTTP service. So it will be the same here, except that if you, instead of using the Hugging Face API URL, you would use your service URL. Yeah.
Perfect. And the other question is slightly related. What if my data source does not have a pre-built component in Hume? Is the tool configurable enough to build my own connectors?
Good question. Hume can, so there is a plugin mechanism where you can create your own plugins if you want. So you can create your own data source. However, as it's built on Apache Camel, there are 300 plus available components. So it would be unlikely that Camel doesn't support it. So if it is not in Hume, we can make it available in Germany for a matter of no time to Orchestra, because it's just reflecting to the UI components the configuration of the connector. Okay, so so if you have a data source in mind, please please tell us. Probably Camel already supports it.
Perfect. Thank you, Chris. I think we will wrap it up here. So thank you guys for joining. Oh, sorry, there's one more question just arrived. Can we consider workflow in such a way that the updates of data in Neo4j is pushed to Postgres? So say there's an update, a company node, and that it triggers the workflow?
Orchestra on its own doesn't handle this, and like there is no way really to handle this. Like you would have to poll. So generally what you're looking at is like CDC, capture data change for Postgres. So there is a very universal way of doing that, which is a tool called Debezium that allows to capture change in Postgres and send them to Kafka. then we can tap into the Kafka topic. So, and then move the change to Neo4j, right? So this is like, it's not specific to Hume, it could be specific to any data integration platform. So this has to be had on the database side, on the Postgres side. Right? So, but there is tooling around the open source also. Debezium is open source to achieve this, and we do already did this for some customers, and it takes really, it's a breeze to use Debezium as well. So it integrates perfectly with us.
Thank you, Chris. This is some incredible on-the-fly response on the question. So thank you, and thanks everyone who participated and joined the webinar. As I said, recording will be sent your way, and if you feel you like what you see in Orchestra and you're not using it yet, drop us a note. We can always give you a demo specific to your use case or your data sets. You can see how Hume and Orchestra can actually be of help to your business problem. So thank you very much. Thank you, Chris, and have a great
Have a good time.